Continuing on with another diagram. Now, here we've got a lot of time that goes on here compared to 1,000. Here we're looking at starting at 500,000 years ago. And the interesting thing here is that over time, we've hit these peaks. And how do you figure out these things over hundreds of thousands of years? The way that's done is there's ice core samples that they take up in the Arctic regions, and that's what you come up with. So it looks like we're headed for another one of those peaks. Let's see, maybe this is 1,000 or something like that. Anyway, this is another thing to look at and say, oh, well, it's not really unusual. The Earth has gone through these peaks back and forth, so this isn't any big deal. The more I looked at these charts, the more I looked at different articles, those that said man is not really creating global warming, that's a natural effect of what's going on. The more I looked at it, the less excited I was about presenting different viewpoints. Instead, it seems like internationally there's a certain agreement on this stuff. So, regardless of what other data you might come up with or other ideas, we're going to have to stick with that. The government is behind it, so I guess let's just go ahead. Let's just go forward with the current ideas and talk about how we're going to solve these things. I think you'll find there's some surprising data about what we would have to do to solve this situation and how some of those solutions are not quite as easy as you might think. This is really intrusive to try to get all these things to happen. And I've got some more pictures for things that so you don't have to stare at my face so much. So let me bring in some more pictures and we'll talk more about it and maybe we can have some fun with it. Here's a big offender of the climate change. This beef out on the range. Cow manure and belches release carbon as methane. So that interrupts the carbon cycle. And then it eventually, through some chemistry that goes on after 12 years, the methane turns into carbon dioxide. So we've still got some problems. So, what are we going to do with the cow? I'm not sure about that. Let's go on to something else. Now we see what, oh, sorry about that. The screen didn't do exactly what I thought it was going to do. Now let's look at environmental impact of different foods. We've already identified that beef is causing lots of problems. Next in line is dark chocolate. That's going to take some thinking about. Uh, Lamb and mutton, and then there's beef. Well, not beef, but when you're doing the dairy stuff's going on. Coffee's not a good one. There must be something about when they grow coffee and dark chocolate that causes some environmental harm. Then another surprise: prawns, big shrimp, the ones that are farmed, that causes problems. Cheese, a big offender. Fish. Now we're getting down to where we can be environmentally friendly. We can eat fish. We can eat pork and poultry. So that's making me feel a little bit better. And eggs are good. Rice, peanuts, cane sugar, all the way down here to nice vegetables and so on. But so if we become a vegetarian, then maybe we'll be in better shape as far as the environmental thing is set up. Now let's go on to more fun. Okay, bunch of words here from MIT, Massachusetts Institute of Technology, quite a prestigious outfit. So let's see what really happens in terms of carbon from the different vehicles. EVs create 3,000 pounds of CO2 per year. Equivalent per year. So, what's equivalent? They're electric vehicles, they shouldn't create any CO2. Well, one of the problems is that the CO2 or the CO2 produced by the factories that are building these lithium ion batteries causes a problem. So, see, you try to fix one thing and then you create another problem. So, here's 3,000, almost 4,000 pounds of CO2 compared to what? Here's 5,000 pounds for plug in hybrids and 6,000 pounds for typical hybrids. Not a whole big difference there. And then the big hit is 11,455 pounds for gasoline vehicles. So when we go for change our cars from gasoline engines to EVs, we're not getting rid of all the carbon dioxide. We're cutting it in about a third, cutting it so it's now one third of that. So sometimes solving these problems isn't quite that easy. Finally, electricity. Everyone needs electricity. So, where's the electricity coming from? Electricity by itself doesn't seem to produce any CO2, so we can do play around with it and not get things messed up. Let's see how we produce electricity. Okay, this looks like a nuclear power plant. So we have kind of dangerous materials that go in there, but we can do pollute a little bit, the warm up the waters that are needed for cooling it and things like that. But nuclear power has been around for a while, and that's one of the choices we can have. So that seems like that's possible. There are some big problems with nuclear power, but right now let's just ignore that. Hydroelectric power, Hoover Dam works great, but the problem is you got to have a lot of water and you got to be close to the water, and that's part of the problem. I mean, Hoover Dam powers Las Vegas, and you've got some various examples of that. So that's nothing new. That's been around for a while. So that's one option, but not everybody can use hydroelectric power because they don't have the water around them like that. Okay, we already talked about nuclear power because so far everything is fine. Okay, wind power and solar power. The solar panels that you see on some people's roofs, or you see a solar farm out there, that all seems to work pretty well, except that for two things. When the sun doesn't shine, no solar. When the wind doesn't blow, no wind power. So you've obviously got some problems with that. You got to fill in the gaps with that. So, biomass. This one's really complicated because it seems just like you're burning the same kind of fuels that you would with a gas or coal fired plant. So, biomass is renewable at least because you can reuse the plants that you're using, and farmers like that because they gives them a use for their crop. But anyway, I don't know why they're showing these cooling towers. It seems more like a nuclear plant. But anyway, moving right along. That's about it. So those are the choices we have, and I think you can probably come to the conclusion that no one of those is going to work out. You're going to have versions of all of those if you want to get rid of all the carbon dioxide. So let's keep pushing ahead with those, and hopefully we can afford enough money to get these things put into place without running our bank account dry. That's what I've got for now. This might be the end of it, and if it is, thanks for listening.